Hello my dear friends, my name is Jigar Kumar Madhusudan Bhatt. Today I am going to present you a talk on turbines. Now let us begin. A turbine is a rotary mechanical device that extracts energy from a fluid flow and converts it into useful work. The work produced by a turbine can be used for generating electrical power when combined with a generator. A turbine is a turbo machine with at least one moving part called a rotor assembly, which is a shaft or drum with blades attached. Moving fluid acts on the blades so that they move and impart rotational energy to the rotor. Early turbines Early turbine examples are windmills and water wheels. Gas, steam, and water turbines have a casing around the blades that contains and controls the working fluid. Credit for invention of the steam turbine is given both to Anglo-Irish engineer Sir Charles Parsons for invention of the reaction turbine and to Swedish engineer Gustav de Laval for invention of the impulse turbine. Modern steam turbines frequently employ both reaction and impulse in the same unit, typically varying the degree of reaction and impulse from the blade root to its periphery. Hero of Alexandria demonstrated the turbine principle in an aeolian pile in the 1st century AD, and Vitruvius mentioned them around 70 BC. The word turbine, coined in 1822 by the French mining engineer Claude Bourdin from the Greek word turbi, which means vortex. A working fluid contains potential energy, pressure head, and kinetic energy, velocity head. The fluid may be compressible or incompressible. Several physical principles are employed by turbines to collect this energy. Impulse turbines change the direction of flow of a high velocity fluid or gas jet. The resulting impulse spins the turbine and leaves the fluid with flow with the diminished kinetic energy. There is no pressure change of the fluid or gas in the turbine blades or the moving blades, as in the case of a steam or gas turbine. All the pressure drop takes place in the stationary blades, the nozzles. Be- Before reaching the turbine, the fluid's pressure head is changed to the velocity head by accelerating the fluid with a nozzle. Pelton wheels and De Laval turbines use this process exclusively. Impulse turbines do not require a pressure casement around the rotor since the fluid jet is created by the nozzle prior to reaching the blades on the rotor. Newton's second law describes the transfer of energy for turbines. Impulse turbines are most efficient for use in cases where the flow is low and the inlet pressure is high. The reaction turbines develop torque by reacting to the gas or fluid's pressure or mass. The pressure of the gas or fluid changes as it passes through the turbine rotor blades. A pressure casement is needed to contain the working fluid as it acts on the turbine stages, or the turbine must be fully immersed in the fluid flow. The casing the casing contains and directs the working fluid, and water turbines maintains the suction imparted by the draft tube. Francois turbines and most steam turbines use this concept. For compressible working fluids, multiple turbine stages are usually used to harness the expanding gas efficiently. Newton's third law describes the transfer of energy for reaction turbines. Reaction turbines are better suited to higher flow velocities or applications where the fluid head's upstream pressure is low. In the case of steam turbines, such as would be used for marine applications or for land-based electricity generation, a Parsons type reaction turbine would require approximately double the number of blade rows as a De-Laval type impulse turbine for the same degree of thermal energy conversion. Whilst this makes the Parsons turbine much longer and heavier, the overall efficiency of a reaction turbine is slightly higher than the equivalent impulse turbine for the same thermal energy conversion. Now the uses of turbines are a large proportion of the world's electric power is generated by turbo generators. Turbines are used in gas turbine engines on land, sea and air. Turbochargers are used on piston engines. Gas turbines have very high power densities because they run at very high speeds. The space shuttle main engines use turbo bomb pumps to feed the propellants into the oxygens into the engine's combustion chamber. The liquid hydrogen turbo pump is slightly larger than an automobile engine, with the turbine producing nearly 70,000 horsepower. Turbo expanders are used for refrigeration in industrial processes. This is all for this topic of turbine, my dear friends. If you would like to know about any particular topic, then please write it into the comment section. I will make a video on it. Please like and share my videos. Subscribe and also subscribe my channel. Thank you for watching and have a nice time.